In this portion of the lecture, this is part 2 of the Chapter 11 lecture. We're going to go ahead and continue from here. Supercall in methods. Overridden methods are hidden, but we often still want to be able to call them. How do you think you would do this? How did we do it before? If we want to call the constructor and the parent, we added the super, correct? So an overridden method can be called from the method that it overrides by simply doing super.method. Compare the use of super and constructors. Much the same. Public void display. Super.display is calling up into the parent, and then we go ahead and add the remaining stuff. Keep in mind that it's going to do everything there first, then these. Method polymorphism. We've just been discussing polymorphic method dispatch. A polymorphic variable can store objects of varying types. Method calls are polymorphic. The actual method called depends on the dynamic object type. A lot of complexity here. In other words, pay attention to the dynamic type. That's what's actually going to get called. So if the method is of type car, it'll go into that. If it's type vehicle, it'll go into that, etc. Okay? So be careful. It's easy to get confused and actually have the wrong methods run on you. This instance of operator is really helpful. So in the case of if I wanted to have code specifically for message posts and code specifically for the other types of posts, I could do if the post object that it has right now is an instance of message post, then do these things. So this way I can cast it to the correct type on my own. You can put this in a switch statement or other statements. There's a variety of approaches to this. It's used to determine the type. The dynamic type identifies the lost information. So in other words, when it's in post, it's lost right now, but it does actually keep a little flag out there to help you out and make life a little easier. It usually proceeds in assignment with the cast to the dynamic type. In other words, once I do this, then I know exactly what to cast it of. Typically, you want to check it to make sure that you're right, because what you don't want to do is try to assign it to the wrong type, and then you get a runtime error, and suddenly you have more problems than you expected. The object class and the methods. Methods in the object are inherited by all classes. Any of these may be overridden. The toString method is a great example of that. I love this method. It's used for printing out a class and its contents. So what you do is if you have an object and you want to see the contents, say for debugging purposes, you would use toString within that class to print out its contents. The default implementation that's in the object method or object class doesn't do it justice, so you write your own and it makes life a lot easier. Returns a string of representation of the object, but you get to implement how it's represented. So here's a simple example. I'm going to do username, new line, timestamp, likes, all this other stuff in here. So now if I just want to do it, I can literally print post in quotes and out will come this. Alright? So I can literally format, do anything I want, and make it as pretty as I want and easy to gain access to. Alright? Overriding toString. Explicit print methods can often be omitted from a class. So here we're doing system.out.println, post.toString. If you haven't done it in the post class, it would actually implement the object one, which isn't so good. And now you can actually make it more formatted. Calls to println with just an object automatically result in toString. So in other words, if you don't do this and you do this, it says, hey, you're trying to convert it to a string, therefore call toString. So Java does a little bit of help for you. I, again, believe in being explicit whenever possible, but this is your alternate. String builder. Now remember before how we talked about a string is immutable in that it actually chews up more memory, and if you're doing lots of operations with string, you can actually have performance problems due to memory issues. So string builder is an alternate approach. String builder creates a new string builder, and then you can use append to actually build the final string. So we're going to append username in there, then we're going to add a new line, then we're going to add the timestamp, and then we're going to return the string version of this builder. So this way, I'm not doing all these memory operations and creating new strings and everything else. It actually glues it together as you go. Object equality. What does it mean for two objects to be the same? To Remember way back in the earlier lectures when we had if A equal B, where A and B were classes, you didn't get the right thing because of the memory address? Well, here's how you would actually compare them. And we did do this with a couple things before, but now we're going to go into it with more detail. Public Boolean equals object obj. So in this case, an object comes in, and first it's going to check to see if the two objects are exactly the same objects in memory. If they are, no reason to continue checking. If they're not of the same type, exit out. If they are the same type, then you get to write the code that you decide what will make it equal or not. Because you know your objects, you know your class, you know the code, you decide how to determine this. So here's an example of an implementation of equal with student. Equals object obj. If they're the same, we already talked about this. We already talked about this. Student other equals student object. So in other words, I'm casting this into a variable named other, and now I'm going to say if name equals the name, the ID equals the ID, and the credits equal the credits, then they must be the same. Okay? So in this case, I actually need to test 3 different fields to see if these objects are considered the same. This is hugely helpful as you work with collections. You'll use it fairly frequently, or if you're trying to just simply compare object to object and you don't want to write a bunch of if statements every single time. This is something that I'm going through fairly quickly, but this is very significant and helpful and is something that you'll want to do. Again, as you work with Java and you do more extensions and you work with more collections, things like this will become more important. So hash code. This person actually borrowed the code from another book, but hash code is another example. Hash code is supposed to be a unique representation of data based on what it's doing. So in this case, they're doing 17 is the start. So they're saying the result is 37 times the existing value plus the hash code of this, plus the hash code of this, plus the hash code of this. So what it's trying to do is create some type of unique value that is returned back, and it's going to use that for comparison. It's an approach. I do use it sometimes, but again, I like the equals much more. This is helpful for certain cases. The book goes into some examples, and again, there is information here for you. So protected access. Protected access is different than private and public. It's kind of in the middle. Private access in the superclass may be too restrictive for a subclass. So in other words, I might want a subclass to have access to the variables that were created in the parent, but you can't if they're defined as private. This is what I've been hinting to as a way around it. You can do protected access, which allows you to gain access to anything else in the inheritance tree. Protected access is more restricted than public access, but not as restrictive as private. As a rule, keep things private because you start to mess up your object-oriented development techniques, and you aren't doing data hiding at the same level that you want to, and you start creating more problems for yourself. Do it the way you're supposed to, but know that you have options as you go through this. Alright, so here's a pretty picture that shows the difference between private, protected, and public. Private is all the way up here at the top, and only things that are in this class can see things that are private. Protected honors the inheritance tree, and then public is for anything, anywhere to gain access to it. There's actually more to this, but it's beyond the scope of this lecture. But if you look at packages, the rules are similar, and there's some additional information you might need to know. To review, declare type of a variable is static. Remember, that's the part on the left. Dynamic is the part on the right. Methods may be overridden in a subclass. Method lookup starts with the dynamic type, and then it goes from there. And protected access supports inheritance, but you want to limit your use of it as much as possible. With that, that's the end of the lecture for Chapter 11. Hopefully you got something helpful out of this. As always, if you have a question, please do not hesitate to write me an email, and I will do my best to answer it. Thank you very much.